welcome to the Gassy laws.
Today, in today's lab, we'll be testing Boyle's gas law. In Boyle's gas law, the temperature is always constant, and with that, it has an inverse relationship of pressure. As pressure goes up, volume goes down, and what that entails is that if you make a bigger room, the pressure of that gas is going to go down. But if you make it smaller, it's going to go up. It has a relationship between.
Oh, dude, I got food coloring on my shoes. Stop it, no. Hey, hit it with one of the hurdles. Do it again!
Should we throw it at them?
Do it. I don't think that one's going.
Oh! I wouldn't even be mad if one blew up on me.
Oh!
Ah!
Bang! You get that on video?
Next, we'll be talking about the Gay-Lusak's gas law. In this law, volume is always constant, which will make it so there will be a relationship between the temperature and pressure that will be direct. What that means is if pressure goes up, then temperature is also going to increase. And another thing about the temperature is that it always must be in Kelvin, which is, again, Celsius plus 273. And that right there will be your equation, and for you to do your little calculations and all that good stuff. Yep. Alright, in Charles' law, pressure is always constant, and what that will have is there will be a direct relationship between the volume and temperature while that pressure is at a constant rate. And temperature will always be in Kelvin, which is Celsius plus 273. And so this will be your equation when you plug in the law or your calculations that are given, and yeah.
Alright, I'm going to talk to you guys about the combined gas laws. In the combined gas laws, no variable is constant. Temperature is always in kelvins, and there's a direct relationship between temperature, pressure, and volume. This right here, this is the equation with P1 and V1 over T1, which is pressure, volume, and temperature. And it's equal to P2, V2, and T2. I'm here to talk to you guys about the universal ideal gas laws. The equation for this is PV equals nRT. P is pressure, V is volume, and N equals number of moles, T equals temperature. And there are other variations of the gas law. And they go PV equals MRT over M, or M equals MRT over PV.
Next we'll be talking about Avogadro's principle. 1 mole of gas is equal to 22.4 liters, and 1 mole of gas is also equal to 6.02 times 10 to the 23rd particles. That's a lot. STP stands for standard pressure and temperature, not in that order, but it says that is at 0 degrees Celsius. Holy crap! Celsius and 1 atm. And then next we move on to Dalton's law of partial pressure, which states that each gas exerts its own pressure, which will bring you to the equation pressure total, which is P total, is equal to P1 plus P2 plus P3, etc. And the P obviously stands for pressure.
Hi there. Today we're going to be testing the ideal gas law. What you're going to need for this experiment is a bucket, a 100 milliliter graduated cylinder, and some lighters. First off, you want to make sure you have safety first. Have your goggles on your face, a fire blanket ready, and a fire extinguisher in case the fire gets out of control. So what we're going to do first is fill up the bucket 2/3 of the way full of water.
What's happening is the butane gas is going up into the cylinder and it's replacing the water. So that way there's nothing but butane gas in it.
Okay, now that the 100 milliliter cylinder is full of the butane gas, you're going to want to raise it up on the water level until the water is even inside of it and outside in the bucket. Right there should be at standard pressure, which should be about the equivalent of what's in the air around us. The ideal gas law states, at ideal temperature and pressure, 1 mole of gas will take up 22.4 liters of volume. Okay, now for the fun part. And then you get a nice little flame when you light it, take it out of the book. It's pretty cool. I like it. And that's the end of the video.
Thanks for watching.